Multiplying complex numbers is in fact easier because we're just going to multiply the values, and then of course whenever we end up with an I squared, we'll replace it with a negative 1. So negative 4i times 3 is negative 12i. Negative 4i times negative 2i would be positive 8i squared. So now notice in this one, this I squared will then be replaced with a negative 1, which would leave me with negative 12i and then minus 8, because 8 times negative 1 is negative 8. But this is not in the correct form, so I would rewrite it with the negative 8 first and the 12i second. For my second one, I'm going to FOIL. 4 times 3 is 12. 4 times 2i is 8i. Notice this one I've got a minus. So a minus 5 times 3 is minus 15i. And a minus 5i times 2i gives me minus 10i squared. So now again, the I squared turns into negative 1, which means this minus 10 times minus 1, this whole thing turned into positive 10. Now combine like terms. Real part goes first, so 12 plus 10 is 22. Imaginary part goes second. 8 and minus 15 is minus 7i. Here are a couple more sort of special case multiplication scenarios. When I have something squared, remember I can't just square each one. That's not okay. I have to actually write it 2 times and FOIL it out. So that would give me 36 minus 42i minus 42i plus 49i squared. And of course, whenever I deal with an I squared, I know that's a negative 1. So this all turns into negative 49. Combining 36 and negative 49 gives me negative 13. Combining these two values gives me negative 84i. For the next one, this is going to come into play a lot with our next section. These are called conjugates, complex conjugates. They're conjugates because, as you'll notice, they have the same values as the first term and the same values as the second term, and the only difference is the operation. They are conjugates because watch what happens when I FOIL them out. 2 times 2 gives me 4, and then that gives me a plus 10i, and this one gives me a minus 10i, and then of course minus 25i squared. Just as before, that I squared turns into negative 1, which makes this plus 25 instead. So what's happening? The 10i and the negative 10i will cancel, and that will always happen when you have a complex conjugate, in this case, like in this case. And notice that there's no more imaginary value at all. I have a 4 and I have a 25, so my solution is 29, or 29 plus 0i if necessary. Really just the 29 is all that's really required there. This will come into play with division in just a moment. Before we do that, go ahead and do both of these practice questions and then press play to check your work. For the first, again, I'm going to FOIL, so that's negative 24 minus 32i minus 6i minus 8i squared. Be very careful, a lot of people forget that I squared. The I squared turns into negative 1, which turns that minus 8i into plus 8. So now I'm going to take negative 24 plus 8, which is minus 16. And then negative 32i minus 6i gives me negative 38i. And then over here, I'm going to FOIL, and if you'll notice, these are conjugates. So I know that those two middle terms will end up canceling out. So I'm going to get plus 30i minus 30i. Oops, wrong order, but you get the idea. And then minus 9i squared, which of course will turn into plus 9, which leaves me with an answer of 109.